This green goo can control pretty much any electronic device, and you can make it at home pretty easily. But would you actually want any of your electronics controlled by this? We'll see. So the idea for this project came a few months ago when I was working on a different project that involved flowing water through some tubes, and even though I was sealing all the tubes and connections, it was still leaking somehow. So after trying all these different methods to seal it, I eventually tried adding this thickening agent called xanthan gum to it to, increase the viscosity of the water and make it harder for it to leak. And it actually worked. And as I watched the gel move through the tube, I had the idea that if we could make it conductive, we could turn it into a sort of liquid wire, and then we could do some really interesting things with it. Like, imagine a wire, but instead of it all being connected or not being connected, you can control how far the electricity extends down the wire. So if you had, say, an LED here, here and here, you can move the conductive liquid down the tube and electrify this part. So this LED lights up, and then this LED, and then this LED. I just thought that was quite an interesting idea. I haven't come up with any useful applications for it yet, but I think we'll be able to make something interesting for this video. So to make the conductive gel, I started by adding some salt, regular table salt, to some hot water to create a saturated salt solution. And then I added some xanthan gum powder to it and blended it because xanthan gum doesn't dissolve very easily in water. But that created a lot of bubbles. I tried removing the bubbles using a vacuum chamber, the same way they do for epoxy resin, for pouring tables and stuff. It looked like it was working because the bubbles all expanded, but then it reached the top of the cup, so I turned the vacuum off and instead I left the gel overnight and a lot of the big bubbles disappeared, so I think that's the best we're going to get. I tried powering this 3V flashing LED through the conductive gel, but it barely came on at all. Even when I held the wires really close together, it just didn't want to light up. So my first thought was that maybe the xanthan gum is interrupting the conductivity of the salt. So I tried again with just a saturated salt solution without the xanthan gum in it, but it had the same result. The LED just barely lit up. So the only other possibility was that the salt is less conductive than I thought it was. I've always heard that salt was a really good conductor, but I looked it up and it's just not. It's a good conductor compared to things that aren't conductive, but compared to things we normally think of as conductors as copper and stuff, which are excellent conductors, salt was just not good. I expected it to be less conductive than copper obviously, but it's 7.5 million times less conductive than copper. So the voltage drop across even a few millimeters of solution is enough to stop the LED lighting up at all. But don't worry, there's a simple solution. We can just double the voltage. Now obviously this is very inefficient because we're just wasting a lot of energy crossing the high resistance of the conductive gel, and it's not really something we can scale up to higher voltages, but we'll fix it later. But now we know that we can power an LED through the gel, we can start playing with it. So I filled a tube with the gel and sealed it on both ends, and then I connected it to a simple LED circuit. So you can see with 6V we can power the LED even through 10 centimeters of gel. So I coloured the gel green to make it easier to see, and then I transferred it to a sort of basic hydraulic setup where on one side there's a syringe full of the gel, which is conductive, and on the other side it's full of mineral oil, which isn't conductive. So now if we push on the gel syringe, the wire sort of moves down the tube. So here's a demonstration of what I was talking about at the start, with the 3 LEDs all connected in parallel. As the wire runs down the tube, it lights them on. 1, 2, 3. And pushing the mineral oil down turns them off. 3, 2, 1. So there is a problem with this setup. If you imagine each block of gel between the LEDs is a single resistor, the first LED has 1 resistor between it, the second LED has 2 resistors, so it's slightly dimmer, and the third LED is even more pronounced. You can see it's much dimmer than the first 2 because it has to travel through more of this resistive gel. So you can see you couldn't extend this circuit for many more LEDs before they just completely didn't turn on. It's also limited in that you can only power things on from left to right. You can't power LED 3 on its own, for example. So to solve these problems, I came up with a new setup that allows you to use a much longer tube and also allows you to use much higher voltages. The solution happens to be my favourite electrical component, relays, specifically these 5-volt low trigger relays. If you're not familiar with how they work, it's just an electromagnetic switch. So you have a low voltage circuit on this side, high voltage circuit on this side, they're electrically isolated. The low voltage circuit can trigger the relay, which closes a switch on the high voltage side, which allows current to flow through the high voltage circuit. So we can basically power whatever we want, even mains electricity, without having to pump hundreds of volts through this gel. So the use of a low trigger relay is quite important in this case. So basically on a relay, you can imagine there's 3 wires. There's a 5-volt line, ground line, and in the middle it's the trigger line. So if it's a high trigger relay, when the signal line connects to the 5-volt line, the relay is triggered and the high voltage circuit closes. But in our circuit, running it through the conductive gel would mean that the signal wire is not going to get 5 volts, so it's not going to trigger because of the voltage drop through the gel. So in this case, if we use a low trigger relay, it will trigger the relay when the signal wire is connected to ground. So I've got this Nixie tube that I want to be able to power with the gel, but because I only want one number to light up at a time, I don't want a whole stream of the gel because that will turn on, 1, 2, 3 all at the same time. So instead we're going to just use a little bead of gel. That also means that the circuit will never have to move through more than a centimetre of the gel at a time, so a high resistance won't be a problem. But with the syringes, there was another problem with leaking, because when you're pressing down on one syringe, rather than pushing out the other syringe, it was found it easier to just leak out of some of the holes, even though they were all super glued. I removed one of the syringes and let all the mineral oil leak out. Then I tried pushing the conductive gel bead with just air in the syringe, to see if that could avoid using all this messy mineral oil. But that didn't work because the bead was just jumping about too much. It was too hard to control how far you're pushing it, and of course air is compressible, so you just sort of press the syringe in, and then when the pressure builds up enough it just jumps along a bit. So went back to using the mineral oil. So to counteract the pressure problem, rather than having a syringe on the very end, I just had the line open but submerged in mineral oil so it can push out easily, and then when it's sucking the oil back up it doesn't get any air in the tube. And that worked very well. I also got this ratcheting syringe thing that lets me inject the exact same amount of liquid each time. So it's got a little dial on here with a number on it, so the ones there, 1 centilitre of liquid per press of it. So that allows me to work out the spacing between each set of electrodes for each number. So hopefully when it's all finished I can just press the trigger and it will move the bead through roughly to the next position. But after all that, there's still a problem with leaks. Rather than the mineral oil getting pushed out of the holes, it's now when you retract the syringe, air gets pulled into the holes. So I mixed up some 2-part epoxy putty and covered all the electrical contacts. This also helped hold them in so they didn't accidentally get pulled out of the tube. I also gave them a couple of coats of a leak-proof spray, and I mounted them on this board. So getting back to the electronics, a Nixie tube is basically just a tube filled with low pressure neon gas, and it's got 10 electrodes in it, shaped like each of the numbers from 0 to 9, and when you electrify a specific electrode it causes the neon gas to glow in the shape of that number. So my Nixie tube has a strike voltage of 180 volts and a running voltage of 150 volts. So that basically means you need 180 volts to get it started, to get the neon ionized. But as soon as it does and it starts glowing, the resistance of it drops drastically, so it only needs 150 volts to keep it going. Also the datasheet says that it needs 2.5 milliamps to run. So from all this we can work out that the resistance I need on the anode is 12 kilo ohms. So I mounted the Nixie tube on the small PCB, and then I added a 12k resistor to the anode. And I have this boost module set to output 180 volts from 12 in. When I first connected the tube, I had the polarity on my cable reversed without realizing, so it caused this weird effect. Once I fixed it, the display worked and I cycled through all the numbers. This Nixie tube can also display a decimal point on the left or right. I wired up the circuit with 10 relays, one for each number. I decided that I was going to turn the Nixie tube setup into a days without incident display. So I made a housing from an old tin that I spray painted black. And then coated with a clear varnish. Then I designed and printed a cover for the front. So now everything's in the housing and working, we just need to connect the relays to the tube contacts. I filled the mineral oil reservoir and pulled it through the tube. Then I added a few centimeters of conductive gel. I made it red this time because I couldn't find my green dye. So you can just about see the red liquid moving through the tube, and then when it hits the 0, it turns on as expected. But from there, the 1 had a bad connection and didn't turn on. And the 3, I think some gel got stuck in it because it's on the corner, so that stayed on longer than it should. So I pulled all the gel back to reset it and had a second attempt. And you can see, you know, there's still a few problems, but it works a lot better now. So there we have it, a Nixie tube display controlled by some conductive gel that you can make at home. Does it have any practical applications? Maybe a tube with some gel sealed inside and contacts on either end, so then when you squeeze it, it can break the connection and act as a sort of rudimentary pressure sensor that you can use in soft robotics. But if you've got any ideas what to do with this gel, let me know in the comments below. Thanks for watching, bye.